Equivalent number sentences. Algebraic thinking. These activities relate to Oswald's Year 4. Use equivalent number sentences involving addition and subtraction to find unknown quantities. Use partitioning to find unknown quantities in number sentences, counting on, and understand the meaning of the equal sign and whether equations involving addition or subtraction are true or false. Equivalence. The concept of balance or equivalence is the basis for comprehension of equations and inequalities. To move towards a more algebraic understanding of equality, students need to learn that the equal sign represents quantitative sameness, that amounts on either side of the equal sign are equal in value. This is an essential understanding that must be in place if students are to experience success in algebra in particular and in mathematics in general. Balancing equations. For this activity you will need counters, paper and pen, a drawn-up picture of a set of scales, a game board drawn up divided into 6 by 6 squares, a set of equations written into each square, e.g. 8 minus 4 plus 1, 9 minus 3, 3 plus 3 plus 2, 6 plus 3, etc. A set of equations to match the equations on the game board, 2 sets of counters in different colours, a variety of equations made up with one unknown. Example, 46 plus 93 equals 38 plus unknown. You also may need to create equations with the sign missing for the extension activity. Example, 23 missing sign 16 equals 49 missing sign 10, etc. I begin by asking students to demonstrate to me different ways to show 5 plus 3 using counters and both addition and subtraction. Encouraging students to generate multiple solutions to 5 plus 3 prepares them for working with variables, understanding and applying the commutative property and the inverse property of addition and subtraction. Students use the language of equivalence such as equal to, same as, not equal to and different from as they add, subtract or rearrange the counters until the scales balance. Okay, Zara. Now here we've got a set of equations with one unknown. Now what do you think is the next step that we need to take?
To make 5 plus 3 on this side?
Yep, so what would you do?
Five plus 3.
Okay, and is that a balanced equation?
Yes.
Is it balanced on both sides? Yep. Okay, do you think you can show me another way to balance 5 plus 3?
4 plus 4.
Yep. And what about one more?
2 plus 6.
Well done. For the second activity, the students are divided into pairs to play a game called 3 in a row. The students are given a set of counters and take turns picking a card. Whatever the card is that they turn, they must match it to an equation on the game board. Given that there are several possible combinations, this gives the students opportunities to further use their skills in number. The first student to cover 3 spaces in a row, down, across or diagonally, wins the game.
8 minus 1.
9 minus 6 is 3.
4 plus 5. 9.
3 plus 2. 5.
3 plus 3 plus 2 was 8.
1 plus 0. 1. Bingo! Back to the balance scales. The objective with this activity is to focus on equivalent number sentences with an unknown, but incorporate the use of partitioning. Partitioning a number into place value can make it easier when using addition and subtraction. Using the following equation, the student is encouraged to use the concept of partitioning as it gives the student an opportunity to employ a range of strategies to solve different addition and subtraction problems. Zara, Can you tell me what we need to do to balance the equation using partitioning?
Work out the first side. 67 plus 21 equals 88.
Okay.
And then to work out the missing number, 88 minus 45 equals 8 minus 5 equals 3. 8 minus 4 equals 4. So the missing number is 43.
Well done. Misconceptions. Students see the equal sign as closure and ignore any digit after the equal sign. Constant reinforcing of this misconception is important, as students can easily fall back into the habit of reading it as a command as opposed to it meaning equivalent to. There can be difficulties moving a student from a procedural to a structural understanding. It is getting beyond this thinking that poses difficulty for many students. Differentiation. For students at a lower level, continue working with lower numbers to balance equations. Using the scales will reinforce the concept of equivalence. Using a wide range of computational strategies will also instill confidence. For more advanced students, use more complex numbers and encourage them to use non-standard partitioning. Using non-standard partitioning means separating a number into parts other than place value to facilitate mental computation. Get students to write their own number sentences, testing other students. Students can also think of a number between 1 and 100, for example, and write down everything they can think of about their number. Questions asked: can you think of any other interesting facts about this number? Further differentiation. Once students understand the concept of equivalence, they can start to work with numbers being relational, looking at the structure of the number sentence to find the missing number. Most students tend to work from left to right, as was shown in the third activity. This means a student is working computationally, which is still effective, but is not looking at the relationship between the numbers. Using 46 plus 93 equals 38 plus unknown as an example, you can introduce the strategy of backtracking. Backtracking enables students to move from a unidirectional to a multidirectional processing, which is more akin to algebraic thinking, as the student relates that the difference between 46 and 38 is 8, and that adding it to 93 gives the missing number. Students apply meta-learning as they are encouraged to examine their thought processes rather than purely attempting to find the correct answer. Extension activities. You can make up a set of equations and omit the sign. Students then have to work out which sign goes with which equation. You can also make up a grid on paper using 5 by 3 inch squares, and at different sides on the grid write equivalent numbers but in a variety of ways. The student has to match their cards with the equations on the square, a bit like the 3 in the row game, but applied as a jigsaw idea instead.